The world is dying, and by that what I mean is it's heating up, and fast. February 2024 marked the 9th month in a row of record high temperatures, 1.4 degrees Fahrenheit above the average from 1991 through 2020. That might not sound like a lot to you, but you should ask the glaciers how they feel. There are many causes for these rising temperatures, but most important is the emission of greenhouse gases like carbon dioxide and methane. In 2020, agriculture was responsible for 5.87 billion tons of carbon dioxide equivalents globally, and that doesn't even count the methane emitted by the decomposing food waste in landfills. According to the EPA, landfilled food waste in the U.S. causes greenhouse gas emissions equivalent to those of over 50 million gas-powered cars. With everything from the gnarly slopes of the Rockies to the entire island of Manhattan, and even Coca-Cola's mascot on the line, it's no wonder that some people finally want to do something about food waste. In general, composting is a better way to deal with food waste than landfilling because it reduces methane emissions, recycles food waste into natural fertilizer, and eliminates the emissions associated with transporting waste to landfills. Black soldier fly composting is different from worm composting because instead of feeding food scraps to worms, it uses soldier fly larvae, which has a few advantages over worms. Unlike worms, soldier fly larvae eat meat, fried foods, and just about anything else. Also, black soldier fly larvae can be separated from the compost and turned into feed for chicken or other livestock. These advantages make it an excellent candidate for neighborhood or industrial scale composting. That's why the EPA granted us a few $1,000s to help solve this trillion-dollar problem. This project was split between two teams. One would develop a bioreactor capable of processing 500 pounds of food waste per week with black soldier fly composting. The other would develop an enclosure to keep the larvae alive and happy while measuring temperature, humidity, carbon dioxide, and ammonia levels, along with energy use and mass flows to help other scientists better understand this composting technique. We spent months toiling over our options. After defining our requirements, many meetings with our client, Sarah Brownell, and countless hours of deliberation, we had two leading concepts. First was a form-fitting enclosure, which would minimize material and energy use, but have the most design complexity. Second was a climate-controlled structure, which would be easiest to design and would allow for more design variability on the part of the bioreactor team. After meeting with the other team and Sarah, our job was clear. We needed to build a shed. With our nearly completed engineering degrees, we got to work designing our shed. Our mechanical engineers, Nick, Jack, and myself, decided on a prefabricated shed for cost and speed and designed an insulation and ventilation system which would keep our larvae nice and alive. Meanwhile, our electrical engineer, Alex, set out to design a power delivery and control system which could handle all the power draws and data collection we would need to achieve our goal. At the same time, our computer engineer, Maxim, began planning our data collection and management to make sure we would comply with the EPA's data management requirements. With our design complete, it was time to build. Only one thing still stood in our way: where to place our smelly box. For a campus as large as RIT, it's really hard to find somewhere to build a shed with electricity. Finally, we found a space inside this big steel fence. This was originally built to support hydrogen refueling, but since hydrogen vehicles have remained 10 to 15 years away from the mainstream market for the last 30 years, it's currently not in service. The availability of electricity, along with the relatively tucked away location, made this a perfect spot for us to get started. And so we leave you here. At the time of filming, we are but a few days away from completing our build, but by the time you're at Imagine RIT, we will be fully operational. Come visit us at the location in your program. We look forward to meeting you. Special thanks to the EPA for funding this project and supporting senior design at RIT.